Guys, let's take a question on quadratic equation, polynomial equation. So the question goes on like this: determine alpha such that the equation x to the power 5 plus 5 lambda x4 minus x cube plus lambda alpha minus 4x square minus 8 lambda plus 3x plus lambda alpha minus 2 equal to 0 has exactly one root independent of alpha and exactly two roots independent of alpha. Okay, so let's see. First of all, since it is the question is talking about independency related to lambda, so we can first separate out that lambda part. We can write down the equation as x5 minus x cube minus 4x square minus 3x minus 2. Okay, so this is the part which is devoid of lambda, and plus taking lambda common, the rest of the part will become 5x to the power 4 plus alpha x square minus 8x plus alpha equal to 0. Okay, so we can modify the equation in this way. So basically one part is devoid of any lambda, and the other part we are taking lambda common. So I guess it is okay, fine. So now you see that since it is saying that the root, exactly one root or exactly two roots independent of lambda, so you can see that the root of this equation, that is the value of x which will satisfy the equation, which will make it 0, that will not depend upon lambda. So this kind of stuff will happen for a particular x when this kind of situation is going to happen, like 0 plus lambda into 0 equal to 0. Okay, like we'll be choosing a value of x which on substituting here we'll be getting a 0, and here substituting the same value we should get 0. Then you can see that 0 plus lambda into 0 in any case will give you 0, and that will not depend upon the value of lambda, because in any case this lambda into 0 has to be 0. So basically you can see that the value of x that you need to choose here and the value of x that you need to choose here for getting a 0 should be same, because we should be putting the same value for x here and here. So from here the concept is like this, that we can argue that this part of the equation and this part of the equation, they should have a common root. Okay, they should be having a common root. Okay, or we can say they will have common root or common roots. Then this is going to happen, because we should be putting the same value of x here and the same value of x here to get 0 simultaneously. Okay, then the roots will be independent of lambda. So now let us separate the two equations out. Like the first equation is x5 minus x cube minus 4x square minus 3x minus 2 equal to 0. So this is one equation, and another equation is 5x to the power 4 plus alpha x square minus 8x plus alpha equal to 0. So these two equations are going to share common roots. So now you can see that since the first equation is completely known to us, but the second equation contains this unknown value alpha, so we can target the first equation and we'll try to find out the roots of this equation. So let's see that what will be the roots of this equation. So x to the power 5 minus x cube minus 4x square minus 3x minus 2 equal to 0. So this is the equation that we'll be talking about, and we'll try to find the roots of this equation. Now interestingly, we can see that for solving this kind of polynomial, we tend to apply a method which is called vanishing method. That is, we try to find out a root by trial. So here in this case, by trial procedure, we can see that x equal to 2 is a root. Okay, that by trial we can quickly derive, because we can see it on putting x equal to 2 here, we're getting 32, this is 8, this is 16, this is 6, and this is 2. So these are getting added to give us 32, and this is 32, so they will be cancelled out. So by trial we have got x equal to 2 is a root. So that means that x minus 2 is a factor. Okay, that's for sure. x equal to 2 is a root, that implies x minus 2 is a factor. So once we get x equal to 2 is a root, so definitely we can gather the other roots of this equation also. Now here, to get the other roots of this fifth degree polynomial, we have to find out the other factors of this equation. To find out the other factors of this equation, what we need to do is that we need to divide this polynomial by this particular factor x minus 2. Okay, so here I will tell you another very fascinating idea of polynomial division, which is called the vanishing method of polynomial division. Okay, it's a very beautiful concept which you can use in other problems. So vanishing method of polynomial division, like we need to divide this particular polynomial by this linear expression x minus 2. So what is going to be the result? So for doing this, what we can do is that like you can see that this is a fifth degree expression and we are dividing by a linear factor, so that should give me a quadratic factor, by quadratic factor. Okay, so I'm dividing this by a linear, we should get a biquadratic, and a biquadratic generally contains 5 terms. So for dividing this particular quantity, this particular expression by x minus 2, so we'll be writing x minus 2 5 times. Okay, so here goes the process. X minus 2 is written 5 times, because on dividing we should be getting a biquadratic. Okay, so x minus 2 is written 5 times. I am trying to divide this polynomial by x minus 2. So this is called the vanishing method. So I've written x minus 2 5 times. Now let's start the process. Okay, so the process will be something like this. Like you can see that we are starting from x to the power 5. So definitely the first factor should be multiplied by x to the power 4, because then and only then these two will be multiplied to give us x to the power 5. So this is taken care of. Now next we can see that we are having the term 2 into x to the power 4, but here we can see that there is no x to the power 4 at all. So to balance this 2 into x to the power 4 term, okay, the very next term should be 2x to the power 4. So for the next one it will be 2x cube. Okay, because this will be multiplied with this x to give us another 2x to the power 4. So this 2x to the power 4 and this 2 into x to the power 4 will be cancelled out. So x to the power 4 part is taken care of. Now next we can see that when this will be multiplied, that will give us minus 4x cubed, right? Minus 4x cubed, but here only minus x cube is there. So we can see that minus 4x cubed need to be added with plus 3x cubed, so that they get balanced to give us minus x cubed, which is present in the equation. So we'll multiply the next factor with 3x squared, because that 3x squared will be multiplied with x to give us 3x cubed, and which on balancing will give us minus x cubed. So this term is also taken care of. Then we can see that this will be multiplied to give us minus 6x squared, but originally what is present? Minus 4x squared. So to balance that we need another 2x squared. So the next factor will be multiplied with 2x, okay, because this on multiplying should give us 2x squared. So this is also taken care of. Then next check out this on multiplying will give us minus 4x, but what is present in the equation? It's minus 3x, so we need a balancing plus x here to get minus 3x. So the last factor will be multiplied with 1 to get this particular term x, and on finally we can see that 1 into minus 2 is already taking care of minus 2. Okay, so we can see that the whole part is balanced. So now what we'll do is that we'll be taking x minus 2 common, and we'll get the biquadratic factor to be x to the power 4 plus 2x cube plus 3x square plus 2x plus 1 equal to 0. Okay, so this is a very interesting idea which is called vanishing method of dividing a polynomial by another polynomial. You can use this method for any other problems. Now let's try to factorize this biquadratic factor further. So for doing that, we can see that this equation can be creatively written as x square whole square plus x whole square plus 1 plus 2 into x square into x plus 2 into x into 1 plus 2 into x square into 1. Okay, this is the creative part of balancing this equation. You can see that this is x to the power 4 is balanced, then 2x cube is balanced, then x square plus 2x square, that is 3x square, will be balanced, then 2x will be balanced, and 1 will be balanced. But here you can see that this part is coming out to be x square plus x plus 1 whole square. Okay, that formula is getting balanced here, because we know that a plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So according to that, we can write down this to be x square plus x plus 1 whole square. And as you know that x square plus x plus 1 whole square have the factors x minus omega and x minus omega square. Okay, so we can see that the roots of these equations are x equal to 2, then omega is repeated 2 times and omega square is repeated 2 times. So these are the repeated roots for this equation. So now let us concentrate upon our original equation. Now this equation is having the roots 2, omega is repeated 2 times and omega square will be repeated 2 times. So these are the repeated roots. And now these two equations will have one common root. For the first case, it says that exactly one root independent of lambda. So in that case, we can say that these two equations is going to have exactly one common root, and that common root has to be 2. So for the first problem, we can easily say that 2 is going to be that common root. So 2 is going to satisfy the other equation. So for the other equation, we can substitute the value of 2 in place of x. So it is going to be 5 into 2 to the power 4 plus alpha into 2 square minus 8 into 2 plus alpha equal to 0. So for the first question, we can find out alpha to be equal to minus 80 minus 16 by 5. So alpha value for the first question is going to be minus 64 by 5. Okay, this is the answer for the first question. And for the second question, second part of the question, it says that exactly 2 roots independent of lambda. So that is going to happen when either omega or omega square, which are the repeated roots, and exactly 2 roots. So omega is repeating 2 times, so omega should also be satisfying this particular equation. Then this is going to happen. Then 2 common roots will be there, because since as we know that in a polynomial, if one root is imaginary, then the other root has to be the conjugate of the imaginary root. So if I say that omega is the root of this equation, so omega square has to be the root of this equation. So omega and omega square will become the common roots of the 2 equations. That part will be clear, I think. Okay, so we can say that either omega or omega square has to satisfy this equation. So putting omega, for solving the second part of the question, it will become 5 into omega to the power 4 plus alpha into omega square minus 8 into omega plus alpha equal to 0. And as you know that omega is the imaginary cube root of unity, so omega cube is equal to 1, right? So we can write down this to be 5 omega plus alpha omega square minus 8 omega plus alpha equal to 0. So alpha into omega square plus 1 is coming out to be 3 omega. And we also know that 1 plus omega square, this is 0. So it is alpha into minus omega equal to 3 omega. So omega on cancelling out, we are getting the value of alpha to be minus 3 for the second question. Okay, so guys, thank you for watching this video. This is my contact information, and in the meantime, please subscribe on YouTube and like us on Facebook to get the video updates. Thank you very much. Bye bye.